5, and in this lab we're going to be going over stoichiometry. We've been doing a lot of stoichiometry calculations, so this is a good application of how you actually use it in lab, why it's important. Okay, so let's check over here before we go over that. This starts on page 84 of your lab pack manual. The worksheet shown below, here it is, so you can put all your data. In the video, what I want you to do is show me the setup of everything, and then I want you to show me when it's done, your results, what percent yield you got, and explain how you could have, maybe done it better, the reaction. Okay, so let's look at this. Here's the reaction we're going to be doing here. Okay, we have barium nitrate. Okay, and we're going to react that with copper sulfate. Okay, and then we're going to get barium sulfate and copper nitrate. Okay, this is called a precipitation reaction here, you see. All that means is that you're going to form a solid in the product. A precipitate, okay, is just a fancy word for something that's insoluble. So whenever these two react together, okay, it's going to create a solid, okay, in the liquid. So you see the barium sulfate is your solid. Anytime you see AQ, that means aqueous, and that means it dissolves in water. Okay, so this dissolves in water, this dissolves in water. If we look at our product, this will dissolve in water. You see this says an S, which means solid. That means this will not dissolve in water. It's going to stay as a solid. It will look like a salt. Okay, and that's your precipitate. Okay, so whichever one does not dissolve, that stays as a solid, that's your precipitate. And if you form a precipitate, it's called a precipitation reaction. Okay, now if this was an aqueous here, and it did not form a solid, this would not be a precipitation reaction. Okay, but it did, so it is. Okay, so that's one thing we're going to be looking at, forming a solid in your product. Okay, the other thing is just doing a calculation. We're going to be looking at what's called theoretical yield, actual yield, and percent yield. Now, here's our reaction here, and to get your theoretical yield, you're going to go from grams of one substance, okay, to grams of another substance. Okay, so let's look at this. We go back and forth here. Okay, so we have these two here. These are our reactants if we want. Now we need to figure out which one is our limiting reactant. That's the first thing you need to do. Okay, so barium sulfate, this is our product we're going to be looking at. We want to see how much solid we're going to form here. Okay. Okay, so if we look here, we want to convert first barium nitrate. How much barium nitrate will form barium sulfate? Okay, so you convert, let's see, this one did not do that. This one here did it though. So we're going to go to barium sulfate. So you convert your barium nitrate first into your grams into moles, which is a 0.00765 moles, and then convert that into moles of barium. Let's see, where's that? Barium sulfate. So basically we're going to go grams of barium nitrate, remember our flow chart, to moles of barium nitrate to moles of barium sulfate. And to do that, you're going to use molecular weight and a mole-to-mole ratio. Okay? Then what you're going to look at is your copper sulfate. See how much barium sulfate it will produce. Whichever one produces the least amount of moles is your limiting reagent. Basically meaning whichever one produces the least amount of product is the limiting one because it produces the least amount. Okay, so that ends up being your barium nitrate here, and it produces 1.79 grams of barium sulfate. Okay, so once you convert it to grams, that is your theoretical yield. Okay, so let's go back and backtrack. So you have your limiting reagent, and that's the one that makes the least amount of moles of product. Okay? Once you figure out which one that is, go ahead and convert it to grams of product. And that is, you just get your moles and you multiply it by your molecular weight. Okay? So you're going to convert grams of barium nitrate to grams of barium sulfate, and that again will give you your theoretical yield. Theoretical yield is, as it implies, theoretically how much you're going to make. This is if everything goes perfect, you measure the exact amount out, and when you transfer, your product into another beaker, you don't lose anything. So if everything is 100% perfect, this is your theoretical yield. This is how much you can make. In this case, it says it is 1.79. Okay? Now, we need to get our actual yield. Your actual yield is how much you actually make. So you're going to do the reaction, and at the end, you're going to weigh your product. And you're going to see how much do you actually make, and that's your actual yield. So that's actually doing a reaction, weighing how much product you make. And then you're going to do your percent yield, and that is actual over theoretical. Okay? So you get your actual yield, what you actually make, divided over by your theoretical yield, and you get a percent yield. And this tells you that you are 92.2% accurate. And this is just an example. You might not get 1.65, you might get less, you might get more. Okay? But it tells you basically how accurate you were. That, you only lost a little bit of product. And sometimes it's not even that you lost product, it's just, the reaction didn't go all the way, so you just didn't get a whole lot. Maybe the reactants aren't very reactive. There's sometimes I see in journals that, they only have like a 3% yield, but they're very proud of it, because the reactants aren't very reactive, but they were actually able to get them to react to some extent. So, percent yield basically tells you how well the reaction went. Okay, obviously 100 would be the best. So this is a good example of how we use actual, theoretical, and percent yield in an actual experiment. The reason this is important because you need to know, how well you did the experiment. If you're a scientist and you want to make a new product, okay, well, you have to calculate a theoretical yield. So you have to know, okay, if I did this reaction perfect, how much would I make? Okay, and then you have to divide it by your actual yield, because you need to know, okay, what if you only have a 5% yield? Okay, well then you have to think, are there ways that I can make it better? Can I increase the temperature? Can I use a different solvent? Can I make the reaction go longer? All of these things can affect the yield, and so it gives you a good idea. So every single time you do a reaction, if you're doing research, you always calculate theoretical yield, actual yield, and percent yield. These are very, very important, and you have to also document these anytime you're writing a journal article. You have to tell everybody what your percent yield was, so they know. So they can see how well you did the reaction. Anyway, so, this is used every day in a lab. And, a very, very important reaction. So hopefully this helps. And if you read these steps here, they say step 1, step 2, step 3, and they go through everything step by step. So, go through that, see if you can follow it. If you need help with anything, please let me know.